Hey guys, in today's video, we're going to go through a very short and simple example of the use of covariance rules. So we have studied 3 covariance rules, and in this video, we're going to go through an example where we're going to use all 3 of these rules, okay? So we have the case where y is equal to b1 plus b2 times z. So b1 is a constant and b2 is another constant times z, which is just another variable, okay? So this is the situation, and we're trying to find the covariance between x and y. Okay, cool. So the first step is going to be to plug in for y. So all I'm doing here in the first step is that I am plugging in for this y. That is, instead of y over here, I'm going to write b1 plus b2 times z. So we're just substituting. That's all we're doing in the first step. Okay, cool. So let me just do that. Right. So in the first step, we're just plugging in for y. So this becomes x comma b1 plus b2 times z. And it's a good idea to use another set of brackets. Okay. So all we have done is plug in y. Okay. So next, what we're going to do is we're going to use covariance rule number 1. And we're going to use covariance rule 1 to write this out. So let me just clarify, this is a comma, okay? Cool. So using covariance rule number 1, this becomes covariance between x, comma, b1 plus the covariance between x and b2 times z. So we have used covariance rule 1 over here, okay? Next, we're going to use covariance rule 3 to cancel this out. This becomes 0 because b1 is just a constant. So the covariance is obviously going to be 0. So I have used covariance rules 3. So 3, and this term right here can be simplified as follows. So using covariance rule 2, let me just erase this and this. Okay, so you're using covariance rule 2. This becomes b2 times the covariance of x with z. So all I've done is that I have taken out the b2, which is just a constant, so we can do that using covariance rule 2. So let me just state what I have used. So we have used covariance rule 2. Like I always say, it's a good idea to explain why you're doing what you're doing. So now we're left with, so this is 0, right? So we can just drop this, and therefore the covariance, okay, between x and y is simply going to equal b2 times the covariance of x with z. And that is our answer. And we're done. Or we're not proving anything. So this is our answer.